Have you ever thought about whether or not we're really alone in the world and there's more to our lives than what we can see? What if the James Webb Telescope shows for sure that our world is inside a black hole? Come with us as we learn more about this amazing news that will make you question everything you thought you knew about the universe. So, what do black holes really mean? They look like something from a bad dream. They may look like things you've seen in sci-fi movies, but the real world is even scarier. Scientists say that they're not just empty spaces with no matter. They're actually huge amounts of matter squished into a very small space. There is a star 10 times bigger than the sun that fits into a sphere the size of New York City. The pull of gravity is so strong that not even light can get away from it. Black holes have interested scientists for hundreds of years, ever since they first thought about the idea of space things that are so big and dense that they could trap light. Einstein's theory of general relativity predicted some of the most well-known thoughts about black holes. A big star basically leaves behind a small, thick core when it dies. If the mass of this core is more than 3 times that of the sun, gravity will pull everything together into a black hole. It's not easy to find black holes because they don't give off any light. Scientists have found ways to figure out if they are there by looking at how they affect things nearby. One example is that if a black hole goes through a cloud of matter between stars, it will pull that matter toward itself. This is called accretion. Normal stars can also be torn apart by black holes if they get too close to them. As they do this, they send out X-rays. Black holes also have a big effect on the space around them. They can eat nearby stars, send out strong gamma bursts, and even change where new stars grow and stop them from growing in other places. But where do black holes come from? Think about this. Stars that used to be beautiful and bright die in an amazing explosion called a supernova. Black holes form from the remains of these giants that have died. A supernova blast is how most black holes are formed. They are made by huge stars that have hit their retirement party in the sky. Smaller stars turn into neutron stars when they die. Neutron stars are very dense, but not dense enough to trap light. But if a star has about 3 times the mass of our sun, it falls apart because of its own gravity and turns into a black hole. As these huge stars fall apart, strange things start to happen near their surfaces. Time starts to bend the rules. From afar, it looks like time slows down near the event horizon, which is where things that are falling into a black hole can't go back. The star's clock seems to beat at a different rate than ours. When 2 smaller black holes hit each other, they can sometimes join together to make a scary and bigger black hole. When a black hole and a neutron star join forces, they make a huge nightmare that is impossible to understand. For years, scientists have been trying to figure out how big these cosmic events are. Black holes come in 2 sizes, very big and very small. We can't seem to figure out what the scary secret is about them. However, there is a catch. Black holes are not all that small. Large stars can turn into stellar mass black holes, which can be up to 10 to 24 times the size of the sun. Tens of millions to a billion of them might be in the Milky Way alone. There are so many black holes there that they could swallow anything in their way. There's more, though. On the other end of the scale are supermassive black holes, which are millions or billions of times bigger than the sun. At the middle of big galaxies, like our own Milky Way, they can be found. It feels like a huge, dark hole that pulls everything toward it. Stephen Hawking, a famous scientist, talked about black holes during his lifetime. His lectures were always very interesting, but some of his ideas couldn't be proven because the right tools weren't available. On the bright side, there is hope. Everything is changing because of one science tool, and we're not ready for it. The James Webb Space Telescope, JWST, is here to look into the very deepest parts of our world. The JWST is not your average telescope. It's a work of engineering genius that shows how far people can strive for success. We have sent other space telescopes into orbit before, and they did their jobs well, but this one is really special. While the Hubble has been helpful for many years, the JWST is much bigger and farther away. This amazing natural wonder costs a huge $10 billion. That's right, that many zeros will make your head spin. This amazing feat was made possible by the work of NASA, the European Space Agency, and the Canadian Space Agency. Over 300 colleges also contributed in important ways. But let's not forget the risks that come with something this big. This isn't a project for easygoing people. With the JWST, we're going to explore new areas, test what we think we know, and visit places we've only thought of. NASA recently said that the telescope has enough fuel to last more than twice as long as its minimum mission life expectancy of 10 years. This comes after a successful launch. The JWST has done a lot of amazing things since it was first launched. It went more than 1 million miles to get to its orbit around the Sun, where it will stay forever. The telescope's huge 5-layer sunshield and huge main mirror were successfully unfolded during its trip. Both of these parts had to be folded up to fit on the launch vehicle. Now that NASA has fine-tuned and checked the camera, it's almost ready to start seeing things. When NASA said that the James Webb Space Telescope had taken its first pictures of stars, that was one of the coolest things about it. The telescope's first picture was of a star called HD 8446. It showed a match of 18 bright dots spread out from the star's light that were picked up by the 18 mirror segments on the main mirror. Later, NASA shared a better picture of HD 8446. This time, the 18 copies of the star that weren't focused were put together on purpose in the shape of a hexagon. After the observatory aligns all 18 parts of the main mirror, it will start the image stacking process, which will make the view clearer by putting them on top of each other. Scientists can use the JWST to look into the early stages of the world after the Big Bang. It has very advanced technology. What happened after the first stars formed is what it will look into. This time is called the epoch of reionization. This age is when radiation from the first stars reionized hydrogen, which means that it got an electric charge again. To do this, we need to look back billions of years, which can only be done with a very large camera like the JWST. Researchers will also be able to find exoplanets with the help of the telescope. These planets are hard to find because of how they interact with their home stars. Its powerful cameras will let it look at these planets more closely and even take pictures of their atmospheres in some cases. Scientists might be able to tell more accurately if certain worlds are habitable or not if they know more about their atmospheres and how they formed. Scientists study galaxies to see how matter is organized on a very large scale, as well as to study how galaxies are put together. In turn, this helps us understand how the universe came to be. There were different shapes of galaxies before they changed into the spiral and irregular shapes we see today. One of the JWST's goals is to study the past to learn more about how galaxies have changed over time. Scientists are also trying to figure out how the different kinds of galaxies we can see today came to be and how they form and put themselves together now. Finally, the James Webb Space Telescope will help us figure out the deepest questions. Are we the only ones in the universe? Or are we living in a black hole? The JWST has already been looking for something, and guess what it found? Polycyclic aromatic hydrocarbons, PAHs, are the chemicals that are found near the 3 active galaxies' supermassive black holes. These ring-shaped carbon molecules are like the Goths of the universe. You can find them everywhere, from galaxies far away to comets in our solar system. Not only are they interesting because they might be the building blocks of life, but they also help scientists figure out how stars form. These PAHs flash and give off infrared light when ultraviolet energy hits them. The JWST's mid-infrared instrument, MIRI, can see this. Most of the time, this means that some hot young stars are nearby. But wait, there's more. Ismael Garcia Bernard, an astronomer from Oxford University, was brave enough to look into 3 active galaxies, NGC 652, NGC 731, also known as the Scary Stephens Quintet, and NGC 749. They are very far away, millions of light years away, and in the middle of nowhere. Now this is something that will make your hair stand on end. Garcia Bernard found a lot of PAHs in the middle regions where black holes rule. That sounds good, right? Now this is scary. The radiation from those supermassive black holes changed the PAHs into bigger, less charged versions of themselves. The tiny PAHs that were electrically charged disappeared. Think about being eaten by the darkness itself. There is a glimmer of hope, though. The bigger PAHs were able to stay alive because they found cover in thin, dense clouds of gas. It's like they found their own covering to protect them from the black hole's terrible power. Maybe you're not sure why this dark twist is important. Okay, you. See, this is a bit of a problem for scientists who use PAHs to study how stars form. The areas where stars are being formed are often full of electrically charged PAHs. If those molecules are destroyed near the centers of black holes, it will be hard to find out where those stars are born. Don't worry, though. Our brave scientists won't give up. The group led by Garcia Bernard wants to go even deeper into this very dark and very deep cosmic depths. They want to look at more busy galaxies, each with its own unique features, to find out how these tough PAHs stay alive in such scary conditions. They are trying to figure out the exact features of PAHs that live in the cores of galaxies with black holes. This information is important for understanding how stars form and how these strange galaxies change over time. What the James Webb Space Telescope really found, though, is something else. Are you ready for some scary news? The JWST may have found what is the oldest black hole in the world. This space monster is a supermassive black hole, which means it weighs 10 million times more than the Sun. We were able to tell what it was by looking at very tiny flashes of light that go back to the beginning of time. This scary, dark object was found in the middle of a young galaxy, only 570 million years after the universe began. Also, scientists think that there may be black holes from even earlier times lurking in the depths of space. It's both interesting and scary to think about what other horrible things might be out there waiting to be found. There is one thing that is certain, though. The James Webb Space Telescope is letting us see into the deepest parts of the universe, and what we're seeing truly amazes us. The finding of the universe's oldest black hole has shocked scientists all over the world. There may have been many black holes during the cosmic dawn, which began about 100 million years after the Big Bang and lasted until the universe was only a billion years old. This cosmic monster could be one of them. Astronomers don't understand how these black holes got to be so big, and how there are so many of them. The researchers who found the newest black hole put their results on the preprint server AR-14, but the work hasn't been reviewed by other academics yet. Astrophysicist Rebecca Larson, who led the study and works at the University of Texas at Austin, thinks that there may be many more black holes out there waiting to be found. She said that the James Webb Space Telescope makes it possible to study the past of the universe in a way that wasn't possible before. She's excited to see what else we find. The secrets of the universe have long fascinated people and scientists, and they have led to a lot of questions about where we fit in the universe. Now that we have powerful observational tools like the James Webb Space Telescope, JWST, we are on the verge of making groundbreaking finds that could change the way we think about reality. The connection between black holes and galaxy formation is one of the most interesting things about the world. There is a complicated relationship between the mysterious supermassive black holes that live at the centers of galaxies and the galaxies that house them. New studies show that black holes might not only eat matter around them, but they might also change how stars move and how galaxies work. This relationship between gravity and matter can control the birth of stars, making the structure of the galaxy more organized. Scientists can see galaxies in their early steps through the JWST, which is a unique way to look at this process. Through studying the light from these faraway galaxies, scientists can learn more about the conditions right after the Big Bang. It's important to know about this time period if you want to know how the first galaxies formed and changed over time, creating the universe we see today. The JWST can collect information from galaxies that were around billions of years ago. This helps us understand the basic processes that shaped the past of the universe. The JWST is meant to study more than just galaxies. It is also meant to study the atmospheres of other worlds. Scientists can find chemical signatures that suggest the presence of possible biosignatures by looking at the light that goes through a planet's atmosphere as it moves in front of its host star. This groundbreaking work could help us find planets with the right conditions for life. This could start an argument about where we fit in the universe and whether we are the only ones living here. The JWST can also see in the mid-infrared range, which lets it study parts of space that are usually hidden by dust. Astronomers can now look into the places where new stars are born, called stellar nurseries. Scientists can learn more about the life cycle of stars and the conditions they need to form by looking into these places. A big part of the past of the universe is the complicated dance of stars changing from birth to death, and the JWST is a key part of showing us how these things happen. The JWST can also look at cosmic events like gravitational wave collisions, which is another important thing about it. When black holes or neutron stars collide, these events happen. They make waves in space-time that can be seen by telescopes on Earth. By connecting these gravitational waves with electromagnetic data from the JWST, scientists can learn more about how these kinds of cosmic events happen. As the JWST keeps finding out more about the universe, it makes us think about time, space, and even the very nature of reality. Every new finding leads to more questions, which forces us to rethink our old ideas and encourages us to keep asking questions. This desire to learn is a big part of why people are trying to understand the universe, and the JWST is proof of how curious we are. The James Webb Space Telescope will change the way we think about the universe with its cutting-edge technology and big goals. It will pave the way for future explorations that may one day answer the deep questions about life that have fascinated people for a very long time. What we don't know yet is still a thrilling mystery that makes us want to learn more about the world and, eventually, about ourselves. The James Webb Space Telescope's job is to find the unimaginable. Who knows what other mind-boggling cosmic shocks lie in wait for us in the vastness of space? There are a lot of mysteries in the world that have yet to be solved. With each new discovery, we get closer to finding out its dark and shocking secrets. What do you think the JWST will bring us?